years.
Hello everybody and welcome to Greg's Vintage Workshop, where I'm working to restore history one piece at a time. Today we're going to do something a little bit different. So for quite some time I've wanted an automatic coil winder. I bought a manual crank coil winder probably 4 or 5 years ago, and it works fine for a coil that only requires, I don't know, 50 or 100 turns. But if you do something that requires thousands of turns, it's kind of monotonous. And there wasn't a good way to really guide other than using my fingers to guide, so I was thinking about there should be a way I can convert a 3D printer to do this. So I have two obsolete 3D printers, a Creality Ender 3 Pro that was converted to Ender 3 Pro V2, and a Ming Rock 3 Pro, which was a bigger printer as far as the build volume and width, X, Y, and Z. And so, long story short, the Mingda printer crapped out. Parts were no longer available through Mingda for it, and I converted it to basically another Ender 3 using the main board and display from my Creality machine prior to me upgrading it. Well, actually, once I upgraded it from the Pro to the V2, Pro V2, I had a leftover original display and mainboard. So I had updated the main to do that, and basically it was just allowed Ender 3 on a bigger chassis. So along came my newest printers, my two new Bamboo Labs printers I've had now for about 1.5 to 2 years that work excellent, and the Creality machine and the Ming machine are basically outdated versions of 3D printers that are no longer useful to me. So ultimately I want to put a laser on the smaller Creality machine, but I decided the Mingda would be a perfect candidate to convert to an automatic coil winder. So basically I don't have hardly any Arduino experience or programming knowledge, and I didn't want to go that route. I wanted something that I could manually tune but still be automated. And so using my 3D printer, my outdated printer, and Tinkercad, and a couple of control boards, three control boards I bought online, we're going to see if I can't create a automatic coil winder, non-Arduino. And so that's the purpose of this video. See if we can do it, and if we can, hopefully somebody else can figure out that they can do it. So without further ado, let's get started. Okay, I'm in the process of stripping my old Mingda Rock 3 Pro down to basically nothing. I'm going to see if I can't convert it into a coil winder. So this is basically showing that I got this thing stripped down as far as I can get her stripped down. I'm leaving the power supply in there because I'm going to use the power supply to power the new drivers that I will be putting in there to control. I'm going to have two stepper motors, one for rotation and one to move the gantry back and forth. This lower stepper motor here is for what's normally the y-axis, and I probably won't need it because I'm going to lock that plate down once I know where I want it, or make it somewhat adjustable, but that stepper motor probably won't be used. It's liable to be one of the ones that I actually use in my setup. Okay, so I'm just kind of designing this thing on the fly. I have this manual coil winder currently that I use, wind a coil, but I want to just, because it'll count, right? And then I can reset it like that. So I'm not smart enough to work with Arduino and write code and all that sort of crap. So I'm just going to basically get two cheap stepper motor controllers and manually control my speed of my winding as well as my speed of my traverse back and forth on my x-axis in order to get the action I need, and I'll put a limit switch on either side to switch to the direction. So I was kind of documenting how I'm doing this a little bit, and This is the route I'm taking. Let me see if I can get this kind of set up the way I want. I'm going to be 3D printing parts as I need to make this all work, but this is the beginning of it, so I thought I'd show you guys. Okay, so this is what I've got so far. I've got the actual manual counter mounted to the base, which the base is now mounted solid. It's not spring loaded any longer to make it all stable and level. And then I created this base, which is blending into, is made out of actually what's called clear PETG, and the actual tower that raises the stepper motor up to the proper height to line up with it and be in alignment, and it rotates very easy. I created a coupler to couple it's about a 1/4 inch diameter D shaft on the stepper motor to the 7/16 inch diameter shaft here with a flat. So I've got a screw to the flat here and a screw to the flat there, and it's working pretty good. The actual tower has got supports, it's nice and strong, all made out of PETG. Took a couple iterations to get, well, actually took 2 iterations. This was my first iteration. I built for that, and I nailed it perfectly for the stepper motor. And then I had to add the tower, which it only took the 1 iteration here. So I had 2 iterations for that, the initial one and this one mounted to this, because I made this, mounted that, and it was good. That gets attached to the base. So that's done, and that all works pretty good. Very happy with that. This is what I created to actually mount the wire roll, which will go behind it once I get that designed. And it's going to drop down a little bit. This is blue because it's just PLA. I decided to start making PLA prototypes because it's quicker and lighter weight than what the PETG is, but all the final stuff will be the clear PETG. So this is the 3rd iteration. I had this one, which was the initial one, and the holes weren't quite right. So I did a second one to add width to it and adjust the holes. And then this one's the final one, which has the top plate. The holes are right. That will get transferred into PETG once I get the rear assembly done. This is going to drop down here. I'm going to use an 023 MIG welding tip to guide the wire out, and then that'll go back to the roll holder with some sort of a brake on it so that it doesn't freewheel. Right now I'm just doing the design stage, which is a lot of Tinkercad design and thought process. This is one of the iterations for the base, but it's coming along. I think this is going to work pretty good. It's all going to come down to the electronics, which I think I've got an idea for that, and I think that's going to all work. So I'll bring you back when I got more to show. Okay, so here's my latest iteration. This should be the final iteration for the x-axis. And on this one, I have got for the arms that will support the roll. This is them here. That's my first iteration right there. And these are the second one. And I've got holes put in them so I can screw those on there. Sorry about that. I should always look through my camera. So yeah, so something like that is what we're going to have. So they get them screwed in there, and obviously that goes through that. Let me get those screwed in there and on there, and I'll bring you back. Sorry about my finger. So we've got the final version of the x-axis mount done. I've got a limit switch mounted over here. I created a little limit switch bracket. I created one for the other side over here, and it has a perfectly sized slide to go within the confines of the channel there. So that goes in there, and then the T-nut That way it allows this to be adjustable wherever I need it to be, and then I can tighten down. I've got one of my limit switches in there. So this one will revert, these two limit switches will reverse the stepper motor when I get all functional. And I didn't bother to put the limit switch on this side yet because I wanted to show you the part. Also, I ordered in some 023 MIG welding tips. Got a very small hole, but basically I threaded the inside of that on the back so that I can just screw that in so it can be changed out if I need to go to a bigger size at some point in time. That goes in there like that. I'm not going to put it in with a wrench, but it's getting pretty snug right there. Now let me show you how the back works. I'll move the camera over there for you. Okay, so the way this works is I've got 3 collars. They'll each one get a set screw that'll go into it, which I haven't put into it yet. But the first one is sized to go on this side. This has a step, and the step is because these rolls have a recess in there. Alright, so here is my pin. We're going to get a collar on there. Well, we'll push it through. We'll get a collar on there. We'll get our wire. Get the right direction. We'll set that there. We'll get our second collar. Put it on there. Okay. And then we'll move that over there. We'll slide that collar up. Push that in. Bring this collar back. And there we have it. Once the 3 collars are locked in place, the spool's centered, and if I need to put a little tension on it so it doesn't like free spin, I can shove one of the little collars a little tighter and then tighten the set screw down, and then that's that. And then we can feed the wire into the lower right here, into our MIG wire feed, and that'll be the feed wire. So that's how that piece is going to work. Okay, so as you guys can see, that's kind of nasty looking there, so I took liberty and printed myself a little Greg's Vintage Workshop coil winder plate that I'm going to glue to that. And then this is a bezel that's going to be for the actual stepper motor driver controllers. It's going to be 2 of them, one for each of the motors, one for the turner and one for the x-axis. So I think I was originally going to mount one on each side, but I think I'm going to put one here, one right in front of it. The table's never going to come far enough back this way to do any interference. Even if it did, they're going to set low enough that would go over it. But I think I'm going to do 2 of them, one right behind the other. I'll cut the holes for that, and then for this hole I just printed the plate for it. It's all on the printer. Gotta get it off. I haven't even seen it. Looks like it turned out pretty good. I printed this cover that's going to go over that. So we'll center it up. That'll go there. So that's currently where we're at. I'm supposed to receive the drive controllers tomorrow, and I'll get those installed. We'll get these other pieces on, and I will bring you back at that point. Okay, so I'm getting ready to solder the 4 transmission wires for the x-axis stepper motor, and I used the original harness, which obviously isn't long enough to make it over to where my new display controllers are. So I'm using wiring that I removed from the harnesses in there to extend these, and then once I get them extended, we can run them over to the display. So let me get started doing that. This one is the B positive. This one is the B negative. This one is the A negative. And this one is the A positive. And that should do that. I won't show you me doing the rotational stepper motor wiring. Basically the same thing. Okay, so the blue tape is basically outlining the cutout for the two controllers. And right now I've got two fans sitting on there in the positions they need to be able to cool the heat sinks of the controllers. And I'm going to measure that out and create a mounting plate for them. And then those will attach to the bottom of the printer, which I'll cut some holes in. When I get that done, I'll bring it back and show it to you. Okay, so here's where we're at. I've got it flipped up. I'm getting ready to do wiring underneath here. I've got my two controllers. The one for the rotate and the one for the traverse are temporarily mounted. I'm going to pull them back out to wire them before I put them back in, because I can't really get to those wires with them in place. And I've cut a hole for the y-axis. I'm going to go ahead and use that to hold the table in place in the position I want it. And I've created some cooling fans for the heat sinks. And right now this is what I started out with, but I actually found I had another big fan right here. So I created another plate for it right here, so I'll actually have two that are going to mount on the base plate to cool here. The two wires here are the power leads for the controllers, and I will be putting two wires here to power the fans. There'll be a third fan right here. I've got a plate made for it right here that will mount down here on the base plate to cool this controller. If we walk around to the other side here and kind of get an idea what we're looking at here. So there's the traverse motor controller and the rotation motor controller, and then we'll have a third one down there. I've got a cover plate which also has a stop plate, so that can only come so far. And what else? What else do we have? Oh, here's the plate for the Y. And I think that's it. I'm waiting for the third controller to come in. It'll be in today. But in the meantime, I think I can get the wiring all finished up. I still have to make a harness for that. I still have to make a harness for that. And the fan harness. So we'll get that stuff going. I got quite the pile of mess here that I'm working with. But turned my puzzle table into a workbench. But we're getting there. We're coming right along. I think that this is going to work well. So let me get some wiring going, and probably get the other controller in when it gets here, and then I'll bring it back. Okay, so I got the wiring all done underneath here. All cleaned up pretty good. I went ahead and I put a third controller in to control the Y-axis. Not like it will get used much at all, not really at all, but it's more to hold it in position. And I got two sets of fan leads, got them quick disconnected. Long ones for the single one down here, which is this single small fan that will cool that one. And then I got the dual double fan that will cool those two right there. These are going to get, this plate's going to get mounted to the base plate that covers all this up. These can come loose on the plate and I can just unplug them. And it physically is turned on right at the moment, so I guess I can show you these fans work. So let me plug these in. And black to black. The unit's on right at the moment, that's why these are running. Okay, there's that one. I'll do this one. Red to red. And black to black. And that one's running. I will get those mounted to the base and get the base put on here, and I'll flip it over and we'll come back and take a look at it. Okay, I've got the fans mounted, and there is actually an air gap besides having the slots vents here. I spaced using a couple of nuts underneath each one of these, so there's about a 1/4 inch space, so the fans can draw not only from those vents but from around them. Same on the other side over here. So those are good to go. I actually hot glued the leads to the base just to make sure that nothing could get in the way and get into my heatsink up there. So all I got left to do is to screw this thing to the bottom, plug the fans in first, plug the fans in, screw it to the bottom, and set it back up, and then we'll come back. Okay, so I got this coil winder completed. Let me come in a little bit so you can kind of take a look at it. These are the controls here for the traverse, which is the x-axis, and the rotation. And this is the one for the y-axis, which is the distance away from the traverse or the coil up here. So depending upon how far away from that I want that to be, I can use that. I wasn't going to put a y-axis on here because it's really not needed. I could kind of move it the way I wanted it, but I wanted to make sure it was held in place, so that's why it's on there. And no z-axis really required, because again I could do the z-axis manually, but it's not going to go anywhere on its own. So that's what we got here. Got the roll all in place and little screws to hold all of the spacers in place so it's nice and centered. Again, I can push on that to get more tension on the spool to keep it from slipping. Made some covers to cover the top of the y-axis and the belt and all that sort of stuff, which normally was exposed. You can reset the counter by just going like that, and it's reset. Yeah, I think it turned out pretty good. I think it looks really good. It's nice and neat inside, and I think that this thing's going to serve me well. Now, I've already done some preliminary adjustments as far as for programming these little stepper motors. One, I've adjusted the amps on. I'm going to adjust the other two before I use it, and I'll show you the traverse is the one I've adjusted the amps down, so it's lower than, you know, I don't want to drive them any more current than I need to. All it's going to do is create heat in the actual motors. And of course I got the fans for the controllers. But let me give you a demonstration. I double checked to make sure that my coil winder and the drive, I knew the drive I was on looked like it was 1-to-1, but I just want to make sure. I put a little white mark on there and checked the number of rotations, and it is exactly what the coil winder is indicating. So let me quick throw you on the tripod and I'll kind of show you how this thing works. Okay, I kind of got you guys an angle. Hopefully you can kind of see everything. I think you can see the traverse. Again, that's where the wire is going to come out. And so let's turn it on. And the traverse is starting automatically all by itself, because that's what I got it programmed at this point. I can adjust how far it goes. I can slide it over here so I need, and then start it. Right now I've got it about the width of what it, like a antenna coil or something like that might be, or an oscillator coil. And so that's that working. I can adjust how fast it goes using the knob here, and I've got it probably faster than it would need to be for winding a coil. Although right now I've got this thing, this is set pretty quick, but I can adjust it as well. So that's the traverse. That's this knob here. I don't really want to mess with it, but I can mess with it a little bit if I want to here, just to kind of show you guys. I speed it up. Alright, so that's that one. And right now I've got it set up so that it's going to run 10 cycles of that. I can run up to 999 100,000 cycles or something like that on. But anyway, it just ran 10. Alright, now here's the rotate. So we'll turn the rotate on. I can counterclockwise it or clockwise it. And it'll just run like this continually. I can speed it up as fast as I want. It's already run 16 revolutions. A little noisy because it's gear drive and it's not no precision thing. Or I can stop it. And then of course the Y-axis bed, I can do that too. So I can reverse it, stop it, reverse it, wherever I want it to be, right? I go all the way to the stops if I want. I can speed that up or slow that down as well. So that's it. It's working exactly like I had anticipated it was going to work. And as I think you guys can see, maybe not, let me get you a little closer here. Put your back a little closer to the actual winder so hopefully you can see the mark I made on there, as well as the counter. Clear it out here. And there's the mark right there. And we'll run it for a minute. Well, not for a minute, but enough you can see that it's pretty accurate. So. Said it went 19 times. I wasn't counting. If you guys were, let me know if it's off. Yeah. So I'm pretty impressed. I'm happy with it. It's going to work well for me when I have to wind something. I don't have anything to wind right now, so therefore I haven't really set nothing up to demonstrate it. But there's absolutely no reason it's not going to work the way I've got it here. So the first time I need to rewind a coil, I'll put another video out here for it. But for now, I'm real happy with it. So this just goes to prove you can build a pretty nice coil winder that's controllable to what you need it to be using an old printer. And the only parts that I bought were the 3 motor controllers, which are available on Amazon, and I think I paid $26 a piece for them. Stepper motors were already from the printer, and I had to create everything in Tinkercad that is on here that you see that's either blue or gray or clear, this is clear even though it looks kind of white. This is PET G, the coupler, and this is all PET G because I wanted to make sure it was dang strong. This one, all it's doing is holding the filament, and so I got it as PLA, and I built in the structure as far as it's kind of got a brace arm on each side doing it anyway, so I think that's going to be fine. I'm in the basement all the time. It's not like it's going to get warm and sag or nothing, so I think that's going to be perfectly fine. If something happens that it would be sag, I could print it and PET G because I have the files. Same with everything else you see on it. The bezels, all that, created on Tinkercad and printed on my printers. So there you have it. I hope you guys enjoyed this. So from Greg at Greg's Vintage Workshop, thanks for watching.